Modeling with Venn diagrams. Constructing Venn diagrams. Venn diagrams can also be made to model different situations to understand their relationship. Start with two groups of objects, each with different characteristics. First, translate the word descriptions of the groups into equations using set notation. Write equations for each set and for the intersection of the two sets. Then populate a Venn diagram with two intersecting circles, one per set. Fill in the overlapping portion with elements that are common to both sets. Fill in each circle with elements that are specific only to that circle, and then populate the space outside the circles with elements that are not in either set. Example 1, Venn diagram. A bag contains 30 plastic discs numbered from 1 to 30. Define set A as discs marked with even numbers and set B as discs marked with multiples of 3. Construct a Venn diagram for this situation. Translate the word descriptions into equations using set notation and draw and label two intersecting circles. So first of all, we have set A, which is all the even numbers as defined up here. Define set A as discs marked with even numbers. So here we have set A as 2, 4, 6, 8, and so on, all the way up to the number 30. We also define set B as discs marked as multiples of 3. So here we have set B, 3, 6, 9, and so on, all the way up to the number 30. Now, we want to look for the intersection. So the intersection of both sets A and B would be the number 6. You'll see that 6 is located in both sets. We also have the number 12 is in both sets. The number 18 is in both sets. The number 24 is located in both sets. And finally, the number 30 is located within both sets. So those numbers are going to get filled in this section right here. Fill in the overlapping section with elements common in both sets. We've determined that the elements common in both sets are 6, 12, 18, 24, and 30. And they are going to get filled in this overlapping region where sets A and B do overlap each other. That is the intersection. Identify the even numbers in bold below, not in the overlapping section, and place them in the remaining section of circle A. Now recall that set A is a list of all the even numbers, or the discs that contain even numbers. We've already identified the overlap numbers that are in common in both sets and A and B. So the numbers in bold are only or exclusively in set A. They would be the numbers 2, 4, 8, 10, and so on. And those numbers are placed here within set A only. Identify the numbers that are multiples of 3 in bold below, not in the overlapping section, and place them in the remaining section of circle B. So recall that set B are the discs that contain the multiples of 3. The ones that have already been included on the diagram, 6, 12, 18, and 24, are here. So we're looking at the numbers in bold that haven't been included so far, and they would be 3, 9, 15, 21, and 27, and you'll see that they have been placed in the remaining section of set B. Place any numbers that are not in sets A or B outside the circles, but inside the rectangle. The universe includes all the numbers on plastic discs that are numbered from 1 to 30. So anything that is not in set A or set B is going to be placed outside the circles but inside the rectangle. They would be 1, 5, 7, 11, 13, 17, 19, 23, 25, and 29. Those are the numbers that are in part of the universal set, but not in either set A or set B. Example 2, Venn diagrams. 100 students at a secondary school were surveyed. The survey found that 75 had a mobile phone, 30 had a laptop computer, and 20 had both a mobile phone and a laptop computer. Create a Venn diagram to model this situation. Start by drawing two overlapping circles. Each set is composed of identical objects. The solution takes a different path from the previous example. We're going to label each circle with phone and laptop. So here we have mobile phone here labeled. In this Venn diagram, it represents the mobile phone. Here we have a label for laptop. And don't forget, we have the label here for our universal set. This represents the entire school population. Identify the number of students that had both a mobile phone and a laptop. That would be 20 total as indicated in the original problem. 20 had both a mobile phone and a laptop. So that number 20 is going to go here in the overlapping region of the students who had mobile phones and students who had laptops. Since the total number of 75 students had a mobile phone and 20 had both a mobile phone and a laptop, we subtract 20 from 75 to determine the number of students who only had a mobile phone. So here we see the arithmetic. We take our 75 students minus the 20 students who had both, and that leaves us with 55 students who only had a mobile phone. Notice that if we take the total number of students, the 55 students who had only a mobile phone, plus the 20 students who had both a mobile phone and a laptop, the total number of students who had mobile phones is still 75. Use the same strategy to determine the number of students who only had a laptop. So we know that there were 30 students who had a laptop. Of those 30, 20 had both a laptop and a mobile phone. So we subtract 20 from 30 to get 10, and we see that there are 10 students who only had a laptop. And again, if we consider the students who had both, 20 plus 10 does equal 30. Finally, determine if any students had neither a mobile phone nor a laptop by subtracting the total number of students who have a mobile phone or a laptop from the total number of students surveyed. Recall that there were 100 students that were surveyed. Of those 100 students, 55 students had only a mobile phone. 20 students had both a mobile phone and a laptop, and 10 students had only a laptop, for a total of 85 students. So we subtract off 100 minus 85, leaves us with 15. That means there were 15 students who did not have a mobile phone or a laptop, and that would go out here in the universal set. It's in neither set, mobile phone set or in the laptop set.